Hello students, today we will discuss the RLC parameters passive elements. You can see in the figure, this is the first figure. This is what the resistor having resistance value. Okay, this is what resistor symbol, resistor symbol. This is what the actual theoretical values where we will be representing the resistor here. It is a practical resistor. Where we identify the value of resistance by using color coding. Okay, in the same way you can see in the next diagrams, this is what the inductor, practical inductor, these are what the inductance or inductor symbols. Okay, in the same way if you observe this one, this figure is the practical capacitors. This is the capacitor symbol. In some textbooks they will be representing this as this way, or some textbooks will follow the same parallel lines. Okay, one will be positive, the other will be negative. This is what the capacitor values. Okay, now coming to this, let us discuss the point 1 of resistance here. Okay, now we will discuss the resistance. Okay, resistance is always denoted by capital R. Resistance is always denoted by capital R. The resistor meaning is a device which provides a force opposing to the charge of flow or the current in opposition for the flow of current, that is what the definition of resistance, in opposition to the flow of current. So resistance is a measure of the flow of current, can be opposed or resisted. This opposing force is called a resistance. That opposing force is called resistance. Okay, resistance symbol is this one. Okay, this is what the symbol for resistor, symbol of resistor. It is denoted by capital R. Practical resistor you already saw it there. Okay, let us define the resistance value here. Resistance is denoted by, so resistance value is defined by resistance R is equal to, it is defined by Ohm's law, which says that resistance is equal to the voltage divided by the current. Is equal to what? Voltage. Resistance is equal to voltage divided by the current. The units will be what? Volt per ampere will be. Units of current will be what? Amperes. Volt per ampere will be nothing but resistance units are ohms. ohms. It is also called as omega. Okay. Next is 1 ohm is equal to 1 volt for 1 ampere. According to Ohm's law, the relation between the voltage and current for resistance is always given by, according to the Ohm's law, resistance is given by, resistance is equal to V upon I, or simply V is equal to I into R. V is equal to I into R. Then the power absorbed by the resistance is, the power absorbed by the power absorbed. We already discussed in one of the class. What do you mean by power absorbed? Power absorbed means current is reaching to the, if this is what plus minus, this is voltage, this is what current. Current is reaching to the plus, current incoming, that is called absorption. Okay. The same positive minus, current is leaving here, leaving from the plus. This is called delivering. Delivered, this is what? Absorbed. You observe the change here. Then coming back to this one, power absorbed by the resistor is, resistance value is nothing but, we know that if we are taking with respect to time for AC, then V into I, that implies, what is V? V is nothing but, what is I? I is equal to V by R, or sometimes V is equal to I into R. You replace this by I into R, into I. Then what we get here? I square into R, the units of power will be watts. In the same way, we can also use one more formula here. Instead of taking V is equal to I into R, let me take here I is equal to V by R. Then V into I is equal to what? V by R. And what we get here? V square by R. Okay, the units of this will be watts only. Okay, in the same way, we can even find the energy. Energy consumed. Energy consumed is nothing but, energy units are, energy formula is nothing but power consumed over a period of time. Power, integration of power over a period of time. Okay. Power consumed, power absorbed or delivered over period of time. That implies integration will be taken from minus infinity to t, p of t dt. Okay, that implies minus infinity to t. What is p of t? P of t you can take vi dt, or minus infinity to t v square by r dt, or you can even take minus infinity to t I square into r dt. Okay, anyway you can take here. To simplify this, if the integration is, if this power is integrated over a period of time, then what we get here? Vi into t. Vi into t. Then the voltage across the resistance is constant. If the voltage across the resistance is constant, means then the energy is defined by W. W is equal to what we get here? If we integrate over Vi with respect to dt, then Vi will be a constant, Vi, and this will be what? T. Vi will be what? Into T. If the voltage is across the resistance is constant, then energy will be constant for t greater than or equal to 0. Okay, this will be what? Changing to t greater than or equal to 0. How? Means that implies integral 0 to t Vi into dt. This can also be written as Vi is a constant integration of 1 dt from 0 to t. Then what we get here? Vi into t minus 0. That will be V into I into t. Okay. I hope this is clear to everyone. Then after that, after the resistance, what we have here is resistivity. Resistivity. Let us take here resistivity. Resistivity defined as the resistivity of the material is defined as the resistance between the opposite faces of a metric cube of that material. For example, it is defined as the resistance between opposite faces resistance between opposite faces resistance between the opposite faces of a metric cube of that material. We will see this derivation in the next class. Okay.